Hello everybody, I am Ljubica Lazarevic. I am part of the Neo4j team working in the developer relations group, and today I'm going to be talking to you about how to keep track of change, and we're going to be specifically looking at time-based versions in Neo4j. So what are we going to cover today? So the first part, we're going to be briefly covering why versioning, why do we care about versioning, and to look at some of the applications that we would use versioning for. Afterwards, we're going to look at how we can do versioning in Neo4j, and then we're going to move into the main body of the talk, which will be going through time-based versioning, where we're going to go through a number of scenarios which demonstrate how we can not only model time-based versioning, but some sample queries that we might use. And also we're going to look at temporal versioning as well, bitemporal versioning. Don't worry if you're not sure what that is, we're going to give a description of that. So just a couple of things to flag to your attention. If you could please, if you have any questions, you'll notice next to the chat window, there is a grayed out Q&A. So if you click on that, you can then have the specific Q&A window, which you can post your question in there. We are also going to be participating in the Hunger Games questions. So those will be appearing at the end of the presentation. So I'll have those posted up, and please do continue putting through any questions whilst you're looking to answer those questions. So let's continue. So why versioning? So the biggest driver for using versioning will be to keep track of change. And we may want to understand how some changes have happened in the application. We want to do some kind of historical lookup, so we want to understand if something have changed, why it has, and so forth. So the other reasons for changing will be what-if analysis. So the reason behind that is, whereas previously we want to look at, previously talked about keeping track of changes, so where does something change? We don't want to delete something, we want to step forward and look at things. On the opposite side, with what-if analysis, what we want to try and understand is if we add something new. So for example, if we add a new service in an IT architecture, if, for example, we're going to add a new service, and it may not be straight away obvious that something's changed, but we want to be able to do this, well, in this future point in time, we're either expecting something to change or we're planning something to change. Can we do the what-if analysis to understand what the impact of that is? And the other reason as well why we might use versioning is tracking dependencies. So an obvious use case here is if you're writing some software and you're using a certain number of libraries, just being able to track if there's some changes in the libraries, we've got dependencies upon dependencies, being able to see what happens when these types of things change. And there are a number of systems as well why we might be wanting to use these different types of applications. So for example, logging access to systems and files as an example. Oh, I believe you're saying you're hearing an echo buzz in the sound. Can you still hear it now? Is it still going on? Actually, one moment. Is that better now? I'm hoping that sounds better and the buzz has gone away. Fantastic. Sorry about that. Okay, so we shall continue. So there are going to be many different types of applications where you're going to use versioning. And for example, you may want to do logging access. So if you're looking at identity or access management applications, as an example, what we'd like to do is effectively be able to analyze, for example, who's accessed what files, what user groups, which systems they've been logging into, and so forth. And the driver behind that is if maybe we want to do some kinds of analysis to make sure that no accounts have been hijacked or some kind of hacking has gone on. So we can have a look at the flow and see if there's any unusual logging in behaviors. Another application, monitoring changes. So for example, if something goes down, or we're adding something in, it may not be obvious that the two things connected to each other. You know, if we add something in, it may, you know, the next neighbor, it may not be obvious that there's any impact, but if we start looking further down, we might see some challenges around that. And another one, collaborative working. So as an example, with collaborative working, you've got different users making changes to documents, and you want to be able to see if there's some changes being made, who made those changes. If you need to do some kind of rollback of changes, you can do that. If you need to be thinking about how you're going to merge things together, that's, you know, the examples of collaborative working. And sort of an example of this as well could be if you're thinking about some kind of entity resolution, as an example. So you had a set of assumptions, you had a set of knowledge when you went away and defined what entities might be related to each other with a certain degree of certainty. And then as you gain more knowledge, more information about the system and the entities that you're working with, you may want to update in the future, and you don't want to delete the previous assumption that you made, but you'll extend the relationship off of there. So you can go off, you can version that, and you go, well, okay, I have greater knowledge now, my certainty has improved about how I did this entity resolution, or actually maybe my initial hypothesis was not correct. I've got new information out and I can correct that and add new information. So how do we version Neo4j? So unfortunately, there is no out-of-the-box solution with Neo4j. This is common across many database systems. And as with many database systems, if you want to have versioning, you will need to think about how you're going to incorporate that as part of your data model. One thing I will flag your attention to is there is within the community group a version of core plugin. So basically, you can go to the GitHub address here. So you go to the Neo4j version of core. That's been put together, and that tries to automate some of the versioning for you as you're inserting data into Neo4j and making changes. To be able to use this, it's very much the same process with the other plugins you may use with Neo4j. So what you'll need to do is you drop that into the plugins folder, the jar into the plugins folder in your Neo4j database with the database stopped. You'll do whatever settings you need to apply within your Neo4j config file and then start the database up. So again, do have a look at that website. So we're going to move on to the time-based versioning. So why do we want time-based versioning? Well, it's very useful for tracking change. And what we mean by tracking change, we don't have to make any deletions. So if a property changes in our data model, if a new thing is added into our data model, we've got a new entity, so forth and so forth, we don't actually have to delete anything. What we're doing is we're using timestamps to be able to show what changes we have made. And when we add these elements and timestamp it, what it allows us to do is step through time and understand any state changes that we've applied to our data. So as an example, we can do that historical look of things if we're looking at changes. We can do that what if analysis if we're putting timestamps into the future. So we have a lot of scope there. And for those of you who were on Max Damars's talk just before mine on modeling approaches, he touched on the process around how we do time-based modeling, sort of this purist way of doing it. And the principles that we apply for time-based versioning is we want to separate object from state. So effectively, what we're going to do is, we've got an example here of products. So we separate the object, which would be the product, from the state. So that will be any properties. And we're going to be capturing changes in the state within the relationship property. So we'll have a look at that on the next slide. So we're going to introduce our first scenario. So we have a company, and this company produces a product called a widget. And on the 4th of May, 2016, they made a couple of decisions. So one of the decisions that they made were they were going to rename widgets to mini widgets, and they were going to reduce the price to $3.99. So if you look on the left-hand side of our diagram here, you can see we've got how we might normally represent things when we start out in Neo4j. We have a node that has a label of products, and that node has a number of properties. So it has an ID of 123, it has a name of mini widget, and it has a price of $3.99. So this node is capturing our new changes, as part of this company's decision. Unfortunately, in this approach, we've updated the node's properties and we've lost that information we had previously. Now, if we have a look at the diagram on the right-hand side, what we've done this separating object from state. So we've made the assumption here that the identifier ID on product is a unique identifier and will always be with that product and not change. And we've then extended out this and created this new node called product state. And on product state, we have the properties there about that product. So the name, the price, and so forth. And what we've done there as well is we've connected product to product state with a relationship. And that relationship type here has product state. And on has product state, we have the properties on there with the timestamp, which indicate the versioning. So in this example here, prior to the 4th of May 2016, the product had a name of widgets and it had a price of $4.29. And as we had this state change happening on the 4th of May, what we've done is we've added a to property on that has product state relationship. So it's the day before. So what we know is that from the 4th of January 2016 up until the 3rd of May 2016, this product had a name of widget and it had a price of $4.29. And then from the 4th of May 2006 onwards, the name's now mini widgets and the price is $3.99. So nothing has been deleted. We've not lost any information. And what we've done is we've captured when the changes occurred. So you have a couple of options here, what you may want to do. And this is very much a sort of what is in your taste, what would you like to do? So some people may decide that they want all relationship types that have the state relationships to have a to property. And you might pick a to property which has a date far into the future, say 2099, December 31st. Or what you might decide to do is say, no, if the state is current, we won't put a to property. So that's very much a decision for you to make. So let's have a look at a number of ways we might query our now newly modeled data that incorporates state information. So if one of the questions we wanted to ask is what's the current product name of product with ID 123, then we have the Cypher query here, match product, and again we've inlined the ID, so match product ID 123. We have the relationship has product state pointing to product state. And you'll notice that we have a variable name of R for the relationship, and we have a variable name of PS for product state. And on the next line, we've got our where clause there. So what we're saying here, because I've not used a to property on has product state that points far into the future, what I'm saying is if the property of R.2 doesn't exist, that is my most current state. So where not exists, R.2, and then we're going to return the name of the product. So return PS, and that will give us the current name, which is mini widget. So let's have a look at another query. So what about we want to look at back in time? So in this example here, how much did product with ID 123 cost 3 years ago? So we've got the same line as we had in the previous query. So match product with ID has product state, And what we're doing here is we're going to set a sort of a bounded query around the time. So in this example, we're saying that 3 years ago today would have been the 10th of October 2016. So we're just putting a filter around that. So that's going to be where relationship from is less than or equal to 2016. And so to catch either, because there may have been a number of price changes since then. So we're just effectively putting this sort of and or in case something has changed or it's still the current price. So effectively R.2 greater than or equal to 10th of October 2016. Or the R.2 property not existing. And then the next line says this is a really nice trick if you've got a list of things coming in and you only want a certain element, either the lowest or the highest one. With PS, so I'm carrying some information down with R as well. So I want those two informations. So what I'm doing here is order by R.from. So what I'm saying is take my list of relationships or my patterns with the relationship there has product state, order it in ascending order, limit 1. So I'm basically going to grab the first item in that list, because we may have a number of product states that meets our where argument the line before. So we're just getting the earliest one, and then that'll basically be the price that was 3 years ago, and then we return the price. So return ps.price. And let's have another look at another query in this example. So what is the stock keeping unit for mini widget? So stock keeping unit would be synonymous with the unique identifier for a product. So that's a term commonly used in any kind of retail. So what we're asking here is we want to know, we've got a name for one of these products, and what you notice here is it doesn't matter what the name was historically, because we're going the opposite direction. So what we're doing here is we're saying match product state with the name mini widgets, and then you can see with the direction of the arrow, so we're going in the opposite way. So we're starting with product state, has product state p products, and then like they're matching, and we don't need to do any filtering because we're going down a specific product name, and then we can do return p.id, and that will give us back the unique identifier for products. I've just got a message saying that there's no audio. Is that the case for everybody? Are you all still able to hear me, or has the audio dropped? Okay, perfect. Thank you. Okay, so we started off with how would we go about versioning the nodes, but we probably want to version relationships as well, because the relationships are going to give us a lot of very useful information about how the dynamic has changed within our graph. And it's a very similar process as well. So why do we want to version relationships? We talked about the relationship between entities will change over time. We want to capture that too. And the principle that we use here is basically we connect the two nodes together involved in the relationship, and we're going to put a timestamp or time range on the relationship as appropriate. So for example, what do I mean with the time range? So in this example that you've got here with the dotted red circle, when somebody buys something, that's a discrete action. It's a discrete thing. You don't keep buying something over a period of time. It'll be a certain point when that happens. Whereas, for example, if this was a customer who had a relationship, say, with a salesperson, then that relationship may have a period of time, and that time will be finite until they have a relationship with another salesperson, as an example. And again, you may, in that example, put a date from and a date to. So that's effectively what we do. Very simple. So here we've got a customer, and that customer buys a product. So let's have a look at our next scenario. So we have a couple of things happening in this scenario. The customer buys a product on the 18th of September 2016, and the customer has also updated their address sometime after the purchase. So I don't know if you can see my mouse. If not, if you look at the bottom little circle, you will see we have that buys relationship between customer and product. So we saw that one in the previous slides. And in that buys relationship, we can see that we have a property there of dates. And in that date, we can see that purchase took place on the 18th of September 2016. Now, we've introduced a customer element here. And much like with product, where the name and the price might change, with customer, they may change their date of birth, they may change their address, and in fact, they're not going to change their date of birth. Maybe there's a correction. So they've put the wrong date of birth in when they filled out the form, and then there's a subsequent correction. And they may change their name. So in that example, it would make sense for us to also separate the customer object from customer state. So again, we have a unique identifier for customer. So here it's 456. We create a relationship coming off customer to customer state. And notice I've not called it customer state here, I've called it customer details. So, feel free to name the parts of your graph with what would be the most sensible naming convention. And you can see here in the larger one, so where we had in the customer buys product, that was a discrete action, it wasn't continuous, so we've given it a discrete date. In the example that we've got here with has customer details, that's going to be, it's going to be a time range. So a customer will live from address from a certain time to a certain date, which is quite similar to the product and product state. So you start to notice that these patterns keep reoccurring, and you see it's the same sort of concept that keeps expanding out. So we've got the example here of Jane Doe. So Jane lived at 30 Orchard Road for a certain period of time. And then on the 5th of March 2017, she changed address to 55 Southfield Street. So you've got an idea. So you can start to see how we're building out this model, how we're versioning different bits of information, both when transactions took place, when personal details were updated, when product information was updated, and so forth. So let's have a look at some queries. And some of the types of queries we might ask around this. So maybe we want to know who was the last customer to have bought product with ID 123. So you can see there, so we do a match product with ID 123, buys customer. So you can see we're going the other way around from product to customer. And we've got a variable name for the buyer's relationship and the C customer label. And then we're using that trick we saw earlier. So with C, so with carrying through the reference for customer and for the relationship, we're going to order by relationship date, descending. So in this way around, we want to get the most recent dates in our query, and then limit one. So we're just pulling the most recent date, and then we're going to take the variables from our query, and then we're going to use the results from that, and then start the second part of our query, which is match C, which we know is customer. R2 has customer details to CD customer details, and then we're doing that where not exists. So what we want to do is we want to get the most current customer name, and then we're going to return the customer name. How about where has Jane lived and when did she move? So in this example, we want to get the address history for our customer. So we're going to do match customer ID 456, because we know that's the unique identifier for that customer. And then we're going to go has customer details, customer details. So we've put a variable name in for the variable in for relationship. We've put in a variable for customer details. And then we're going to return distinct, because there may be a number of updates that have occurred where it wasn't just the address that was updated. So we're going to return the distinct address as an address. We're going to return the from date at that address, the to date from that address, and then we're going to order by the from date. So I just want to quickly put a side note about capturing updates. And again, this is very much going to be what works best for you in your model. So what you might want to do when you're updating things, and this is very much going to depend on the types of queries that you're doing, who's going to use the models and so forth. But for example, here where we've got changes to customer details, we may decide that we want to capture why we made the change or what have you. So this is very much going to be sort of tastes and the types of questions you're looking to answer. But for example, we may decide that it makes sense to capture a reason on put a relationship between state changes and a reason why we made that state change. So it's very much a decision around that, and it may aid with some of your querying. So for example, if you just want to pull address changes as an example. Okay, so the next part is managing retrospective changes. Why do we want to manage retrospective changes? So these are the bitemporal changes we mentioned at the start. And the reason why we may want to, why we want to think about capturing different types of ranges is because if you think you have a bank account as an example, and you place a deposit in your bank account at a certain date, and then sometime in the future you discover that that deposit you put in never got recognized by the bank. So you pick the phone up, you contact the bank, and you say, something's missing. And this deposit I put in, it's not in the records. So effectively the bank will go, sorry, they'll make a correction to their system. And what they're going to do is they'll put a correction in, and they'll put the amount in that you deposited on the date that it should have put in, i.e. the date you deposited the money. But they're also going to capture the time at which they made that correction. And they're going to do that because it provides an audit trail, and they'll have regulatory obligations to show that. And it's also useful to understand if there's something going wrong in the system. So if there's continuously certain transactions being dropped, you can investigate further to see what might be causing them. And you can also do things such as what if analysis, another analysis based on different temporal types. So you can start seeing, well, what happens if I change this, but this remains the same? What happens if I change this, but this changes, and so forth. So you can do some really complex analysis on that. And the principles for doing bitemporal modeling are pretty straightforward. So what we're going to do, whereas before we used one timestamp or timestamp range when we were doing time-based versioning, for bitemporal versioning, we're going to use two timestamp or timestamp ranges. And one of them is going to represent what should have happened. So we may call it the business date, we may call it whatever is appropriate to describe in that domain. And we're going to have another timestamp that represents when something actually happened or when something actually got corrected, and so forth. So let's have a look at another scenario. So building on our product customer scenario, what's happened? A customer buys a product and something happens and there's a failure and that transaction is lost. And what happens during a stock take a month later, it's spotted that there's one item less, was one mini widget less than was on the stock taking list. A bit of investigation goes on, a shipping note is found, and we discover that that item's up. So we want to rectify that situation. So if we have a look at the diagram. So if we have a look at the red dash circle, which is the higher one up, you will see we've got a customer here. So customer Jane Doe bought the product, and the business date when that product was bought was on the 18th of September 2016, and the process date. So when the item should have been mapped as a transaction, and when the item was actually mapped as a transaction, the process date, they both match. So basically everything's fine there, everything behaved as expected. Now, if we have a look at the bottom red circle here between the product and customer, which links to John Brown, we can see what's happened here. So if you have a look, we can see the business date here is on the 9th of May 2017, but you'll notice that the process date is further along in the future. So it's on the 30th of June 2017. So the 30th of June was when they did the stock taking, and they discovered there was one item less in the warehouse than what should have been, and they've done that tracing back. So effectively what we've done here is we've captured when something should have happened, so when that transaction should have taken place, and then we've got the process date of when it's corrected. And that's going to be really useful for things like being able to retrospectively calculate what your sales figures were. Maybe there's a problem with the system, and if it happens for a certain product or a certain set of catalogue of items which are stored in a certain system, maybe that needs to be explored. Maybe there's some triage that's required there. So we're going to have a quick look at some questions here. So I'm going to go through these quite quickly. The slides will be available later. We're running a bit short of time. But very quickly, if we wanted to find out how many transactions were missing that we retrospectively captured, so that's quite a simple query here. So what we're saying is match customer buys a product where the business date is less than or earlier than the process date, return account. So that's going to tell us how many times did it arise where we had to make retrospective corrections. Maybe we want to find out about captured transactions for the past year. So in this example, we want to know about the times where the transactions and the process date were the same. So there's nothing missing there. So in this example, same pattern, match customer buys products where the business date is equal to the process date and the business date is greater than or equal to 10th of October 2018. So we want to know captured transactions for the past year. And then we can return that information. And last but not least, if we wanted to know about all of the actual transactions, so basically we want to know about all of the transactions, both the corrected ones and the ones that happened as we expected. So in this example here, we're saying where business date is, oh, sorry, that should be the other way around, where business, no, so this is all the actions. Yeah, so we want to know about all the transactions past year. So what we're doing here is this is ignoring any corrections that we may have done later on. So we're saying for all the transactions that happened on the 10th of October 2018 or later, and returning all that information back. So there are some advantages and disadvantages to this approach. So the advantages are we're capturing, and this is both for the time-based versioning and the bitemporal versioning, we're capturing all the changes to date, including relationships. We don't have to delete anything. We have that full audit trail available to us, and we can step forth back in time and understand exactly what happened. We can roll back any events and so forth. There are unfortunately some disadvantages with this approach. So these approaches, so one of them, need to do additional work to model changes in relationships. Unfortunately, we don't have indexes on relationship properties. So what this means is if you start having dense nodes, so this is where you have many relationships coming off a node, you need to start thinking about how can you remodel that. So you may start to look at things like bucketing nodes or time trees and so forth. And some of the querying can become more complex. So what I've shown you is quite a purist view. So the key thing here is be pragmatic. If, for example, you know your customer node is never going to change ever, maybe you don't need to separate object from state. If there are some things where you can slightly modify the model, go for it. So it's very much going to be driven by the types of questions, what your data domain looks like, and so forth. So very quickly in the summary, unfortunately, versioning is not available out of the box. It is data model based, but this is common across many databases. And the principles of time-based versioning is separating object from state. We extend this to relationships by including timestamps in the relationships that connects between the objects. And we can also use this to capture when things should have happened and when it did. So it's giving us that bitemporal view, being able to capture corrections as well as when things happened. There are some challenges to approach which might make it slow depending on the data model and any corrections that you make. And there is always room for pragmatism. And we mentioned before the version of core plugins might be useful, so please do go have a look at that and see if that is a good fit for your problem. So thank you very much. Some details, you can find me on the Neo4j community forum. You can tweet me. I write some articles on Medium as well, so do reach out if that's helpful. And we're going to take some questions. So what I will do, I will bring you over onto the Hunger Games questions. I will also paste you the link for into the chat window so that you can have easy access to those. And we'll start going through some questions. Okay, so would changing the states be less, more efficient, or better organized? I'm just trying to see if I understand. So changing the state, it's very much going to depend on. So there's, if I've understood correctly, there's a number of things you can do. So depending on what you think is going to change, you may either decide to what we call rarify your model. So you may decide, well, I've got an object. So for example, we have product, and product has an object. And we might decide to say, well, actually, we're going to have a separate node coming off products, which will have, for example, product name state. We might decide to have another one comes off, that's product price state. You may choose to verify that. I think this is, we're starting to describe pragmatism. So if you think certain elements are going to change quickly, but you're not going to query them very often, and there's some other elements that change very slowly, and they're going to query them often, then it could well make sense that you split those out. If it's the case of, for example, with, say, customer, where the customer state realistically changes very, very slowly, you might take the pragmatic approach of saying, well, actually, my querying is a lot simpler if I keep all of the different details that might change for a customer in just that one customer details node. So it's very much going to be dependent on the data you're modeling, what types of questions you're looking to ask, and they could well be one of those may be a good choice for you to pick. Is there a way to make the current state a default in the model so you don't have to explicitly ask for it in the query? And yeah, so that potentially yes. So what you might decide to do is you might decide to say, well, actually, the majority of my queries are always going to be for the current state. I'm only keeping track of any changes for historical purposes or an audit trail. And what you might decide to do, you might decide to add a new label onto the node. So in Neo4j, you can have more than one label associated with a node. And you might decide, actually, I'm going to create another, I'm going to label my node with another node label, which is current or current state or something like that. And then what you could do in your queries, you could do, for example, with object, you might say match p product colon current state as an example, and then that could simplify your query. So again, it's very much going to depend on the types of queries, but absolutely that may well be a potential approach that you use. How does this strategy differ from saving the current details on the customer node, and when changes are made, saving the old node in a new old customer node with the dates they were changed? So the one thing that might be worth bearing in mind, so if you're changing the label of the node, it may cause some complexity in your queries. So again, it sort of touches a bit with the previous question. If you know you're only ever going to ask about the current customer and you don't mind a bit of query complexity, then it could definitely be approached. But it's just something to bear in mind that you may find that you've got less flexibility within your queries to be able to do that. So it is something to bear in mind. It's that fine balance between the types of queries you're going to ask, what kind of questions you've got from your data, and what flexibility you want in your queries. How do I feel about keeping historical items as a linked list with the most current closest node? So I think what you're trying to suggest here, if I've understood correctly, Dave, is to effectively chain the node. So you've got, say, a product node points to next state, product node points to next state, product node. Potentially that can work for you. So where that might work really well is if you always want to go, you always want the node at the top of the tree, or you're always going to refer to the oldest node, then potentially that's a structure that you could use to speed through it. So some of the challenges perhaps to watch out for is if you're going to be commonly asking for things in the middle of that list, there may be some challenges around either the complexity of querying, or maybe it might be a bit slower, but again, it's going to be driven by the types of questions you're looking to answer. So, there are many questions. I'm impressed. Okay, so we've got another question. So unfortunately, this will have to be the last one as we have run out of time. The question is, can Neo4j enforce relationship integrity, say to make sure that the dates or date intervals do not overlap for the relationships from the same node? Unfortunately, that's something that's going to have to be driven by your query logic and your data model. So that's something that when you're doing the updates or insertions, you need to watch out for. So what I've seen a lot of clients and Neo4j community users do is they'll effectively build out a stored procedure, and that's going to be very much locked down to their data model and the types of questions looking to answer, and that's going to manage the details with regards to making sure that dates overlap. So for example, they may go and pull what the previous date is in an increment and so forth. So yeah, so unfortunately, not out of the box. That's something that has to be managed by your query logic. So anyway, thank you so much, everybody, for joining me today. I hope that was useful. We will get the slides out to you. If you have more questions, please do. For example, you can ping me on the various mediums that we've shown up there, and have a fantastic rest of the online summit. Thank you.